product rule. There are several rules that we've learnt so far in terms of differentiating different types of function, but one type that we haven't looked at so far is if we have two functions being multiplied by each other. For example, if we have x sine x or sine x times log e of x. So when we have more than one function, we can't derive that using any of the rules that we know so far. So we need to come up with another rule to help us do that. That's what we'll be learning today, which is called the product rule. There is a full proof for it. I'm going to flash it very quickly on the screen, which is this. You can have a look through it. I do suggest that you do and try to figure out what's going on, but obviously it's way too long for me to explain. So, but that is the proof as to how we get the product rule. Now, what does the product rule actually look like? Even though this looks like it might be confusing notation, what we've got here is that the derivative of a function which is u times v. So if I've got a particular function, let's call it y, and that is going to be equal to u times v, so two functions here, what I can see is I've got the derivative of this function by x is equal to my u function multiplied by the derivative of v plus my v function multiplied by my derivative of u. Now, even though this looks quite confusing, you can also write it in another manner. Even though it's not formal notation and we probably shouldn't use it as our final answer, it is fine to use as shorthand. So if we take one of our functions to be u, the derivative of u, we can write it as du by dx, or as shorthand, we can write it as u dash. In the same way, if we have the derivative of v is dv by dx as shorthand, we can write it as v dash. So in general, what we can say is that the derivative of a function y, so dy by dx, is equal to the function u times v dash plus u dash times v. So it's quite easy to remember. It doesn't really matter what order you do it in because they're being added. As long as they're being multiplied, one of them is the derivative while the other one is the original function. So let's try and apply this. Example 16. Find f dash of x is if f of x is equal to 2x minus 1 in brackets times root x. So your first step is to recognize what are your functions u and v. So let's call this function here u and this function here v. Now I like to set it up like a little table. So if I say u is equal to 2x minus 1 and v is equal to, I'm just going to straight away write this x to the power of a half, then u dash is equal to 2 and v dash is equal to a half x minus 1 half. And now the product rule is really just being multiplying by the opposite, because the product rule f dash of x is simply equal to u times v dash plus v times u dash. Or if you remember these arrows, it's just a little bit easier to be able to do so. So that will be 2x minus 1 multiplied by a half, x to the power of a half, negative half, plus x to the power of a half times 2. Now we can go ahead and simplify this. So the way I'm going to write this, because it's a fraction, this is a positive power, I'm going to write that up at the top, and then I'm going to take that square root of x down to the bottom. Now the other thing that is at the bottom is this 2, so that will remain at the bottom there. That's plus 2, and then x to the power of a half is the square root. And so that there is the derivative of this function. B, find f dash of x if f of x is equal to x squared minus 1 all squared times 2x minus 1 cubed. Now it's quite easy to see what is our u and our v in this case, so this one is clearly u, and this one here is v. So once again, let's set it up like a little table. So u is equal to x squared minus 1 all squared, v is equal to 2x minus 1 cubed. Now let's find the derivatives. This is the chain rule here, so I'll take the 2 out the front. I don't touch the bracket and I subtract 1 from the power. 2 minus 1 is just 1. And then multiplied by the derivative of the inside, which is 2x. So if I simplify that, that's just 4x, x squared minus 1. And then v dash, I'll take the 3 out the front, subtract 1, which makes it 2, don't touch the inside, and then multiply by the derivative of the inside, which is 6, 2x minus 1 squared. And now again, what we're going to do is use our arrows. It doesn't really matter which way you do it. So before I did it as u v dash, this time I'm going to do u dash v and v times u, v dash times u. So it literally doesn't matter. As long as you cross them, then you'll get the right answer. So let's go ahead and write all of this out. So f dash of x will be equal to, so this time I can do u dash v plus u v dash. So as long as each of these, one of them has the derivative, the other one has the original, and vice versa in terms of what it's being multiplied with. So this time I'm going to do 4x x squared minus 1 multiplied by 2x minus 1 cubed plus, and then we're going to do u v dash. So that's x squared minus 1 squared times, I'm going to put the 6 out the front here, 2x minus 1 squared. And there's nothing else that I need to simplify with this answer.